Alright, this is a demonstration of automatic throttle control using the analog output of the PLC. The screen here for the CW80 control has been updated to show that I have a throttle feedback, which just simply takes the track power, runs it through the analog control box, which just converts it to a DC signal and sends it back to the PLC so that it could sense the approximate track power. Because the CW80 doesn't output a clean sine wave, it's actually more of a triac output. These numbers at percentages are a little bit off, and it's, I'm going to have to try to figure out a way to see if I can make it a little bit more accurate. But the main purpose for it is that in the event of a derailment, or if the transformer overloads and shuts down, that the PLC could sense that the transformer's track power shut down and could react accordingly, such as throwing a hard alarm. Going all the way back to my around-the-wall layout, I've had this compensation box, which basically, as I turn the rotary switch, it adds back-to-back diodes to drop the voltage as the train enters blocks that are on a downgrade. This is because my house isn't level. So, say where the train's parked right now, the thruway west and the main line south tend to be downgrades, and this thruway east and the main line north tend to be upgrades, uphills. So what this would do is then when the train would enter those blocks, they'd have full track power, and then when it entered the downgrade blocks, it would be reduced by whatever the selection is. But with automatic control, I'm actually able to enhance that. So thankfully, because of finding this signal isolator, which basically takes the 10 volt 0 to 10 volt output from the PLC and just outputs the same voltage, but it's electrically isolated, and then it goes through here to a voltage divider to convert it into a 0 to 3.3 volt voltage, which then becomes what would be the equivalent of this wiper throttle output. And of course the CW80 has to be goofy in the fact that when the throttle is set to 0, the voltage being sent to the circuitry is actually 3.3 volts, and goes lower to 0 as you increase the throttle to 100%. Well, enough of the goofiness. I'm going to start the train up and show the throttle control and the offsets. So of course this has to be the good old blue goofy guy, so let's hopefully this thing will run forward without too much of a problem. Powering up, starting in reverse, rather slowly, I must admit. Now, of course, the goofy guy had to mess up, but it finally decided to go forward. So anyway, so what this shows is I have the base setting, of the throttle control, which would be basically where I would set the wiper, and I could raise and lower it by 5% just by using these arrows. And then this is the actual throttle output, which will change depending as the train passes through the blocks. As you can see, it's actually being reduced in certain areas and then actually increased in other areas. That screen is right here. So when the trains pass through the thruway east, I actually increase the throttle by 10% and then slowly fold it back down to a 15% reduction in power when the train goes through the downhills. So this actually kind of smooths out the speed of the train a little bit better, because I could actually fine-tune it by actual blocks. And as you can see, actually runs pretty smoothly. So as the train passes through different blocks, the throttle is changed accordingly. And then if I want to, I could just simply turn it all off, and it would just simply be the straight, whatever the setting that I have set here, say 65, if I go to 70, it's going to stay at 70% no matter where the train is. And you'll see how much speed the train picks up in that block, and then actually loses some speed in these blocks. So this is just a simple demonstration. Finally got the analog throttle control for the train working in the CW80. All thanks to this blue little guy, the signal isolator. The reason for that is, years ago somebody drew up this schematic of the Lionel transformer, and unfortunately this is the original version of the CW80, which Lionel quickly discontinued, where the A is the track power, the B is the accessory power, which I use to power the remote switches, and the U's are the commons. And to be able to detect the train in the blocks, I have the U tied to DC minus on the 24 volt power supply. The original version actually had the A and the B's tied common, so this output was actually inverted, which caused a lot of problems, which is why Lionel quickly updated it. So unfortunately, I mean, this is the triac output section, which is why the output to the track isn't a clean sine wave. So they updated this, so the U's are now actually the common, but I don't exactly know how this circuit really works now, because this would be shown as the common, which I would think would be to the U, which when I metered it, it was a very low ohms. So when I wanted to tie into the wiper, the throttle control, which this is also designated as a common, when I tied the PLC's common to this terminal, it blew the internal fuse on the transformer, shorting it out. So that obviously there's something updated about this, and unfortunately nobody ever redrew an updated schematic of this. So thankfully, because of the isolation, you know, I'm able to connect to that throttle. And I also placed the fuse outside externally, because it's actually very hard to get to inside the CW80 to change it. So I just have it external here with a small automotive fuse. So, well, in the event if I blow the fuse again, I can easily change it. So this is why I had to find some way to isolate the input to the CW80 for throttle control. The relays for the direction, whistle, and bell didn't really matter, which is these relays here. They're isolated from the rest of the system, so these always worked without a problem. It was when I went to try to tie the analog input from the PLC, output I should say, you know, to provide the 0 to 3.3 volts to automatically control the throttle, that caused the problem. So this has been finally resolved, so now I have much finer control of the speed of the train around the track. So this is a demonstration of throttle control with a PLC. Until next time.